Alright, today in the flipped classroom we're going to be talking about section 6-6, which is all about linear inequalities, trying to set them up, solving, and finding out if a point is on the line of a linear inequality. So for our first example, we'll jump right in. We need to try to find out if the point 7, 3 is on this line. So what we'll do is we'll take our x, y value, plug in the values, and see if it holds true. So my y is 3, my x is 7, 3 is less than 6. So for this particular inequality, 3 is less than 6, this is true. So we would say yes, this point is on that line. So just a quick explanation of it. What I'm going to do is put up a diagram for you to be able to use as a reference in your notes. So the different ways that we can write inequalities are all four up here right now. So in your notes, please make sure that you have this. So these are all the symbols. We've already gone through inequalities in general. So we know that this inequality symbol here is greater than. This one here is less than. Greater than or equal to. Less than. Or equal to. So just as a refresher for you on each one of those inequalities. So now the part as far as when we get to graphing these, and you're going to see that here when we get into a couple of example problems. So how to graph these, a greater than means that we are going to have a dashed line. Less than also means that we're going to have a dashed line. The reason for a dashed line is because it's not actually on the line. Greater than means that it can be larger than that number, but it cannot be equal to that number. Same thing with less than. It can be less than that number, smaller than that number, but it cannot be equal to the number, therefore giving us a dashed line. Greater than or equal to, kind of like the problems that we've been solving already, it can be a solid line. It can include that number, that whole equal to part. Same thing with less than or equal to. It can also be on that line, therefore making it a solid line. Now, the tricky part for us is knowing what way to shade an inequality when we're graphing it. So the greater than symbol, greater than means that we're going to be picking numbers that are larger than the number that we already have. So when we shade our graph, we are going to shade above. Less than means that we are going to shade below. Greater than or equal to, above. Less than or equal to, below. This should be in your notes as a table for when we get into the lesson. So now getting into examples of those types of problems. We'll start off with something fairly simple. Y is less than 3x plus 4. First thing, I'm going to take that 3 and turn it into a 3 over 1. Keep in mind slope, rise over run. Next up, I have a graph, and I need to just simply graph what I see here. So treat this just like a y equals mx plus b type of problem, but instead we've got an inequality. So I'll begin with my 4, 1, 2, 3, 4, put my first point. Using my slope, I will go up 3, 1, 2, 3, and right 1, my second point. I'll do this one more time, up 1, 2, 3, and right 1, and make my third point. So nothing is different between equations and inequalities up to this point. The difference is I need to look at the inequality and see if it should be a dashed or a solid line. Looking at the less than, I see that it should be dashed. Meaning that my line will look like this. The slope is going up, it's a positive slope, so that checks out. It's a dashed line because it is less than and not less than or equal to. Next, I need to know where I'm going to shade my answer. Going back to the graph, less than, I'm going to shade below. So what this looks like is we're going to look at our line and we're going to shade below, do this in a different color. I'm going to shade below the graph. Notice that I'm using the majority of the graph to do the shading and not just right next to the line. What this means is that if I pick any coordinate point in this area, it's going to make this inequality true. Just to prove that, let's try a couple of examples. So the easiest one to always use is the origin. So we'll take the origin and this is telling me that it should make this inequality true. So 0 is less than 3 times 0 plus 4. Well, 3 times 0 is 0. 0 plus 4 is 4. 0 is less than 4. This is true. That makes sense because I've shaded this entire region. These should all be true. So 0, 0 works. Let's pick one that may or may not be as easy. So let's try 1, 2, 3, 4, comma 1. And see if that's true. So I'll take the 4, plug it in for x, the 1, plug it in for y. And 1 is less than 16, which is true, keeping all of this true. So as an example, let's pick one that might not be true. Let's pick one somewhere over here, like -3, comma 1. Still want to try to keep the numbers easy, but something on the other side. So -3, comma 1. So plugging this in, 1 is y, and -3 is my x. So 3 times -3, -9 plus 4. Now 1 is not less than -5, meaning that this is not in the shaded region. Well, we've graphed this already. It's just a way to check, make sure that our answer is correct. So this would be how to graph y is less than 3x plus 4. The second example that we'll do is an example from one of the homework problems, and we'll try to make it a little bit more challenging. -y is less than or equal to -x plus 4. First thing that I need to realize here is it is not in the form y equals mx plus b because of the negative. In order to get that negative out, I'm just simply going to divide everything in the inequality by a -1. That'll cancel my negative, flip my inequality. Since I'm dividing by a negative coefficient, negative divided by negative is a positive, and positive divided by a negative is a negative. And just to keep things right in the world of slope, we're going to go ahead and add that as a 1 over 1. And from here we just need to graph what we see. So I'll begin at the -4 and make my first point. From here I need to move up 1 over 1. So it's changing at a rate of 1 over 1. And from here I need to draw my line. Now taking a look at my line, greater than or equal to means that I need a solid line, and then I'm going to be shading above. So I'll have a solid line just like we're used to drawing, and I'm going to be taking and graphing the shaded region above the line. And if I were to take any of these points, plug them into this or this inequality, I should get that it is true, that y is greater than or equal to -4. Many of other, or 0 is greater than or equal to -4. So many other examples, you could take any of the numbers in here and it should work out just fine. The last one that we'll do is y is less than or equal to -1/2 x plus 3. It's already in slope-intercept form. The y is isolated. Looks like y equals mx plus b. So I'll begin at my +3, put my first point. Second point, down 1, right 2, down 1, right 2, down 1, right 2. Slide back over. I'm dealing with less than or equal to, so I know that it's going to be a solid line, and I'll be shading below the line that I create. I've got a solid line here, and I will be shading below the line. So I'll look anywhere on here, and I'll shade anywhere below that line. Take your origin as an example, plug it back in, check your work. Zero comma 0, -1/2 times a 0 is 0. And yes, 0 is less than or equal to 3, and this is your solution. So these are a few examples on how to graph inequalities. The main part is this graph that should be able to help you out, table, to help you out on how to graph an inequality.